Morning, sir. Good evening.
Good evening, sir.
Yeah. So how are you?
Fine, sir.
Good, good. So today we have uploaded all the softwares in our machines. So Monday we'll be meeting. Mani sir, you are from which college?
From Sweri College, Pandharpur.
Pandharpur. Okay. So you'll be coming on Monday.
Monday.
Monday you have to come. Yes.
Okay, sir.
Hmm. How is the rain there in Pandharpur?
Sir, still raining, sir.
It's raining. Here also it's raining. Yeah.
Yes, sir.
So you are from very, very religious place, the Pandharpur.
God, Vithala and Rukmini.
Correct, correct. Yeah.
For Monday offline session, sir.
Monday offline, so you can come. 9:30 will be starting, so you can plan and you can be here.
Sir, if I'm not able to attend this, then
They try to attend at least few. At least you
because
manage from your level.
I started today only. So
You just think of, okay, you let me know, okay, when you can come.
yes, sir. Yes, sir. I will try.
Yes.
शुक्ला सर
हाँ जी, yes sir.
सर फर्स्ट डे जो लीनियर रिग्रेशन का जो पीपीटी और मटेरियल है ना सर एक बार शेयर कर किए तो हम लोग भी सर एक बार देख लेते सर
I will put again that also in the group, and also I will share you that, sir. Okay.
ओके सर ओके
That is there, no problem. I'll give you, sir. Yeah.
ओके सर
Siddharth, we would like to start now.
Yes, sir.
You are ready?
Yes, sir.
Okay. Sonal?
Yes, sir. Should we start?
Yes.
Okay. Am I visible and audible?
Uh,
Just,
no,
yeah.
you. Yes.
So good evening, everyone. This is Sonal Surve, your host for the day. As we all know that artificial intelligence technology has revolutionized in terms of academia, in organizing classes. So today's world has witnessed a tremendous innovation in artificial intelligence, machine learning, and deep learning. So, in the past few days, we witnessed amazing sessions by our esteemed guests. So, today I would like to welcome you all to the day 4 of our program. Shukla sir, over to you now.
Thanks a lot, Sonal. Yeah, so it has been a very warm beginning, and we'll see that. Okay, like yesterday, we had a very beautiful sessions. We enjoyed till the end a lot. So now we hope the same that we are going to have a very nice session even today also. So now to take it is the time for taking reflections from the participants. So I would like to invite some of the participants, and they can just express that what they learned and how they're feeling at the end of the day 3, at the beginning of the day 4. So anyone can come forward and share his or her experiences. Yes, anyone, like, okay, we have yesterday learned about the decision tree, and also we learned about the entropy, and also the Gini index, and also anyone can, yes, you would like to give your reflections on that. Dr. Abindra or Mane sir. Yeah, yeah, Rabin sir, please. Yeah.
Yes, sir. Yesterday, we started attending from day before yesterday, from 6th onwards. And the first day we learned with logistic regression. And yesterday the day started with decision tree model, which is once again a classification model, and where the classification will be starting with the root nodes, and wherever the root node once classified to a downstream level where it ends, it is called the decision nodes. So the classification progresses to such an extent that there is a fruitful information emerges out from the data, which helps in predicting the dependent variable. A lot of advantages and disadvantages have been explained and covered, where decision tree it gives us very easily in a tangible manner models out of the classification, with some of the disadvantages, just like overfitting is the main the negative attribute of a decision tree. And the decision tree model generally gives information basis of four points, like a Gini index, state statistics, information gain, and the reduction in variance level. Uh, the things we started with taking one iris data set example, and develop the model there. However, a little bit due to my difficulty in net connectivity, Gini index I couldn't able to cover up in the last session there.
Yeah, yeah. Thanks a lot, Dr. Ravin sir. Yeah, it has been, you have given the very beautiful view, outlook of that, whatever we have learned. And I would like to invite Mani sir if you want to share something on that. Mani sir had many questions yesterday. So in fact, like, okay, we are having certain, the ICT has kept certain rewards. So those who are participating and they are very their contribution to this particular FDP. So we are having some awards and rewards for them. Oh, that will be disclosed on the maybe the final day. So kindly just share and participate and express yourself during the workshop.
Sir, I missed the first day because of the college work.
Okay, okay.
Decision is very good. Third day, the decision tree. I don't know about the decision tree and AI. Sir explained very smoothly, and example is given very nicely. So all concept of decision tree are clear myself. And Google Colab, I never used a Google Colab, but because of sir, I know that this can be used like for the data sets. Nice session, sir. Last session.
Yeah, yeah, very
Thank you.
nice. Yes, yes.
Thank
So even Google Collab was really very interesting. That anywhere and
you.
we can use it. So that is very handy in that way. Yes.
Thank you, sir.
Thanks, Pramod, yeah, for sharing your thoughts. Now, anyone else would like to, without my inviting, if anybody would like to share? Anyone can, yes. Anuradha ma'am, over to you. Or anyone else who is ready to share? Yes, Anuradha ma'am. Okay, friends. So, okay, so I think yes, some of you would like to express. Like before that, even I would like to share something like what are the AI tools which we are using in education? Because we see that there has been a drastic change, like before COVID and after COVID, and the education sector has become more dynamic after with the use of this AI. So I was just listing down, and then I found that how that the AI has helped us, especially in education sector. So just I will share my this thing on. So my thoughts on this. Like we have seen that the enrollment ratio has increased with the use of AI because we are able to monitor the how many students are enrolled, and they are able to access. Even we are able to do the whole process online, and then hardly the human involvement is there. So that has helped us, and now it requires only that we need the human interaction only at the time of when we want to verify the real-time documents. Then also, like it has, I find that is it has decreased the drop ratio because now we are able to with the use of the Google Class and the other tools, we are able to in touch with the students every time, even those who are absent and they are able to contribute to their the assignments. It has also helped us on the online attendance system. So we are able to take the attendance every time and we can monitor the attendance. Even for the assessment, it is helping us in a better way. Also, now we find that the earlier we used to talk only the smart classrooms, and now we find that the it is a reality, and we are just recording the lectures, and we can reproduce it. We can share it to our students like whenever they want. We are able to create the different kind of apps to be in more touch with our student community. So many institutes we have seen that they are able to create a app, and through the app they are they are in much better way to connect with them. Also now we find that even the home learning is possible. The with the virtual home learning we can do it like we are doing here. We are all also like talking about the outcomes. So that is again in that we find the even outcomes can be monitored and it can be assessed in a good way. Talking about the HEIs, okay, the higher education institutes. So we find that the even the quality assurance can be maintained with the use of the AI. In that we can check the with the use of AI, we can check the plagiarism, we can check the timely submissions and the other things. We are also able to do the lot of trainings. We are also able to do the different kind of research in collaboration with the different higher HEIs, the higher institutes and educations. Also, like I find that the even the student participation has increased that with the use of AI. So even while using the hybrid system, we find that okay, we can be always in touch with the students. So these are some of the things which I was noting down, and I was thinking how the artificial intelligence has helped us in education sector. So like in governance also, it has helped a lot. So these are some of the points which I have shared and I wanted to share with you. Now I would like to invite like if anyone else is ready and want to share something about like before the Mithun joins, so you can come forward. Anyone? It's a yes. Uh, Anyone can share, okay, how you are using the AI tools in your day-to-day, the even the classroom practices and also.
Hello, sir.
Yes. Hi, sir. Welcome. Yeah. Yeah.
Yes, sir. I was just listening to the conversation. Yes.
Actually, you were there. Okay. I
Yeah,
was
yeah.
just thinking, okay, to my yes, all
No, no,
participants. Yeah.
no, no, no. I was here. I was just listening to the discussion.
Okay. Good. 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 So we were discussing about that the how AI has changed the education sector and
Definitely,
how.
definitely.
Oh yeah. Yeah. So yeah. So again, a warm welcome to Mukul sir, the Mithun sir. And Mithun sir, we had a very positive feedback yesterday. Everybody has enjoyed your decision tree model and also the Gini index and whatever the models you have taught yesterday. So also I have shared the PPTs we have which you have given it and all the material, the reference materials. So once again, I welcome you and on behalf of all my participants, I request you to kindly take it forward and uh, give us the what is the new in this particular area, the artificial intelligence and machine learning. Okay, so now it is over
Sure.
to you. Welcome, Surya.
Sure. Thank you so much, sir. Okay, so I was just listening to some of the discussion and some of the points that have been raised. So if you look at the journey that we have taken, day one was mostly about linear models, linear regression model. I request you to keep 3 points in mind. Linear automatically means that we have to keep in mind the fact that there should be a linear relationship. We looked at heat map, we built a linear regression model. Fundamentally, there the dependent variable has to be scale. Once we have a scale dependent variable, the story proceeds from there. The story proceeds from there in the sense that we have a set of independent variables, we regress it on the dependent variable, we get the output, we get the coefficients which are called as rate coefficients. We look at the p-value to say whether it is significant or insignificant, right? We split the data into training and testing. Three crucial metrics are R square, which means coefficient of determination. It always lies between 0 and 1. Close to 1, the model fits the data well. Close to 0, the model does not fit the data well. That's how you can basically interpret it. Then we have, we moved on to day 2, where we looked at logistic regression model. Fundamentally, linear regression model is designed to handle relationships when the dependent variable is scale, right? Many times we see the dependent variable may not necessarily be scale, like fraud detection, defaulting on payment, whether a person is high risk or low risk. All these things are not really regression problems. They are what we call as classification problems, because we are trying to classify customers into one of the two groups, or one of the two groups mainly. Yeah. So when you have only two classes in the dependent variable, it is called as a binary class problem. And binary class problems can be used, can be addressed through logistic regression model. We saw how a S-shaped curve or a sigmoid curve, is useful there. Then we moved on to day 3, wherein we spoke about nonlinear models. Yesterday, we looked at decision tree model, and we looked at some of the advantages of using a decision tree model. A decision tree model is what is called as a rule-based approach, because we saw how rules and such things can be easily obtained. There is not much of science and such things. It's a lot easier than logistic regression model, right? It is a lot easier and lot easier to understand also. And we saw 4 methods basically: Gini's quotient, entropy, chi-square, cart method. Some minor variations are there. My request to you is don't worry too much about the formula and such things at this stage, right? Here, what I'm trying to impress upon you is the application, right? Some of you may be interested in the mathematics behind it. If you're curious about the mathematics behind it, fine. I would always urge you to look at the application, right? When you have a tool, how can I apply it? Can I solve a real life problem using this? That is how I would encourage you to think. There are beautiful algorithms, but the question is, what does this algorithm do? Right? 101 algorithms are there in the market. At the end of the day, you should ask yourself a question: what does this algorithm do? How does it? How does this help me solve my problem? Right? That is. That is the main crux of the matter, right? Can we solve business problems? So with this background, right, yesterday we covered nonlinear model. I'm going to talk about another technique today. Let me just quickly introduce you to this particular technique. Right, it is called as market basket analysis, right? It is not really a technique. Market basket analysis is in the business application, and the name of the technique is basically what is called as a priori technique. It does not. It is very simple. This is a technique which is very simple. It is commonsensical method. There is not much of statistics or machine learning. It is just pure common sense. That is what we are going to do. I didn't want to. Speak about too much of theory and such things. In fact, because there's not much of theory and mathematical motivation and such things. It is not some super sophisticated hi-fi technology that we are learning. It is just a simple technique. I'll tell you what is market basket analysis firstly. See, when you go to a retail outlet, right? And I'm giving the example of retail outlet because this is mostly used in retail outlet itself. In a retail outlet, what happens is that you have many different products. If I walk into a retail outlet, maybe I just want to buy a pant, right? I just want to buy a pant, but I also see a beautiful belt that matches the pant. So I have not gone there with the intention of buying a belt. But when I look at the pant color and the belt color, it matches so very well. So I pick up both of these things and bring it home. I bring both of these things home, right? Now, you may see this as a recurring pattern in the sense that out of 1,000 transactions in your computer that you have recorded, many people who have bought a pant may also have bought a belt with each other. Or there may be a tendency that you buy oil and let's say salt together, right? So sugar and oil may be selling, salt and oil may be selling very, very well together. Or it could be that you go to a shop, you buy chips, and you also end up buying egg, or you may buy ketchup along with this, right? So these are what are called as co-occurring items, right? Items which sell very, very well together. Not one item, but these are multiple items which can be cross-sold together. There's a tendency for people to pick up one item, and they also tend to buy another item along with this particular item. So this is what is called as cross-selling. Now, this is from a consumer's point of view. Now, consumer does not have to think about all these things. He is interested in, okay, can I buy egg? Can I buy rice? And can I buy some other item? But if you are a seller, this piece of information is very, very important to you, because this will help you identify cross-selling opportunities. If a person buys item A, can I also sell B to that person? Right? Who are the persons who are likely to buy shirt and belt together? Who are the persons who are likely to buy salt and oil together? What is the profile of those people who tend to buy each of these items together? This is a simple cross selling. This is what we call in marketing language, this is called as cross selling. You have bought one item, I'm going to cross sell, I'm going to recommend other items as well to you, right? It may also work with books and such things. Let us say you are fascinated with Agatha Christie, who's a famous author, and you love to read her books about murder mystery novels. Now, given that I know that you have bought Agatha Christie's books, can I cross sell, Sidney Sheldon's books to you? Or can I cross sell Jeffrey Archer's books to you? Or possibly I could sell somebody else's books to you. It could be Dan Brown, or it could be any other book, right? So this works on the principle of cross selling. If you buy item A, how likely is it that you're going to buy item B, C, and D? So this technique, so this is a business application which is called as market basket analysis, and people have been using for the last 20-25 years. Now, a couple of things here. Now, I said oil and salt. I said basically shirt and pant, or belt and shoes. These are commonsensical approaches, right? In UK, sometime back, they did a study, and they found out that when they picked up the item in certain stores, there was a tendency when they analyzed this. They found out that there's a lot of tendency for Britishers to buy diapers and beer bottles together. You might have heard of this example. It's a very famous example. People tended to buy diapers and beer bottles sell very, very well together. People who buy beer bottles tend to buy diapers. Now, when you look at this, apparently there is no connection between, there is no relationship between a person buying diapers and beer bottle, right? Unless the person is so drunk that he can't even go to the restroom. That's a different case. But what is the connection between diapers and this? But then upon closer examination, what they found was that usually this tendency to buy diapers and beer bottles was amongst the men. And this behavior happened mostly on the weekend. Why weekend? Because in just as in India we are crazy about cricket. In UK market, in UK in general, people are crazy about soccer. So for the 5 days, the women would do the babysitting and such things at home. The men would work, but on the weekend, it was the men's responsibility to do the babysitting. So on Friday night, what they would do is basically, since the next day they had to do babysitting, they had to pick up diapers. They would pick up diapers for their kids, and they would pick up beer bottles so that they could enjoy a game of soccer while doing babysitting. So this tendency of so this is one thing. But more than the explanation, as a businessman, we are interested in, can this item be cross-sold? If one item can be cross-sold, it will help me revenue. So the technique that we use to perform market basket analysis is what is called as a priori algorithm. We will be using what is called as a priori algorithm. Okay, a priori algorithm. So this is not a supervised learning technique. I just have a set of products and I need a truth table. Truth table means the data is very simply binary. Either you have bought the product or you have not bought the product. That's what I need, nothing else. demographic details and such things are not that useful while doing a priori algorithm. So this is a very small case study in retail, which I'd like to take you through, and how they have sort of applied a priori algorithm and such things to, solve certain problems. We'll look at this a priori algorithm and try to find out how we can use this. At a very high level, let's look at the problem statement here. A UK-based retail company, Datacom, they have got more than 800 store outlets. And they sell a wide variety of consumer products ranging from men's apparel, women's apparel, groceries, and kids wear. So when you have so many items, the question is which item will best sell with which other item. Why? Because if I manage to sell 8 to 10 items, your brand loyalty will grow up. On the other hand, if I sell only one item to you, a person with only one item, his loyalty itself is not there. Tomorrow he may leave you. Correct? So brand loyalty and such things can be increased by cross-selling multiple items. Some of the questions here, at a very high level, what products do our customers like to buy? This is the thing which at a very high level, give me the list of items which our customers tended to buy. What are the most trending items? When I say most trending items in the last week or in the last month, which are the items which have tended to sell well the most? Thirdly, what is the profile of the customers buying these items? Fourthly, which items are selling best with which other items? So the fourth part of it, when you look at the fourth part of it, this is where we have applied the cross-selling. This will likely help in planning promotional strategies for future. Which items are selling best with which other item? Lastly, can we reduce the mailing expenditure by identifying profitable customers? So the technique that we are going to talk about today is the answer for the last part of it, right? The last, when you look at the last but one, right? Which items are selling best with which other item? We can use cross-selling. So I'm just telling you how analysis actually is useful, right? There are so many tools here. You can see here to answer this problem. There are many tools that you might have to actually use. So firstly, to aggregate the base data, right? Because the base data is not given in Excel the way I was showing you. The base data is not given on a platter and say, boss, you take this data, you can use it. It doesn't work like that. In a real-time scenario, the data, demographic detail, people will store in one table, and then account details in another table. And then you may have to merge these two tables, demographic, account details, product details, and such things. And then you'll aggregate the base data. How do you do it? Through SQL. You need SQL for it. Once you do this, then to get some preliminary charts and such things, you can use OLAP cubes, online analytical processing cubes, pivot tables. So you can use certain elementary statistics and such things through Excel. The third step is basically wherein you use dashboards. You construct dashboards, and to construct dashboards, you need Tableau. Nextly, for basic analysis and such things, we can use basic statistical analysis. You can use R. And if you want to do some advanced analysis, you can do through Python. So this is the pipeline that you have to follow. May not be always, but mostly in a real-time scenario, this is the 5-stage pipeline that you need to follow when you analyze any data, right? You need SQL for base data preparation, then Excel for summary reports, for graphs and such things, dashboard preparation, Tableau, and then R and Python. So usually you can see here, the base data looks like this. You can see here person week, account details, campaign week. You have to merge all these things using a primary key. Then campaign week has to be merged with product table. And finally, you aggregate it with department to get the base data. If you do all these things, then your base data may look something like this, right? Store ID, healthy food. This is the final data that you see. But the background behind assembling this data is a lot of merging and such things. So you can see here, to answer some of the questions, what we have done, right? At a very high level, we are doing a box plot. This is part of what is called as data wrangling and munging. Again, part of AI, right? I know people may be excited about algorithms, neural network, and such things. It's good to be excited about algorithms. But before that, you have to do a lot of data exploratory you have to use exploratory data techniques. Why? Because this data set is dead. It doesn't have any life at all to it. It just has a few it has just a few facts and figures. Look at this. When you look at the distribution of amount of money spent for 3 sets of customers, clearly you can see that the box plot at the center is at a high level, which means that people who spend for self and family, they're big spenders. Next, you can see here, males tend to be bigger spenders because the thick line at the box plot is higher for males. So these are two insights that I can get, right? So the third point is basically when we do a simple line chart and such things, what we can get is basically you have three sets of customers: bi-weekly, weekly, and often customers. And on the y-axis, what we have is basically the estimated marginal mean. You can clearly see that the blue line is at the top. Now, this blue line corresponds to males, which means that basically men tend to be bigger spenders as compared to females, right? So what I'm saying is basically why is this important? This is important because this is the exploratory data analysis, and exploratory data analysis itself will give you a lot of early warning indications even before you build a model. So before building any model, I would always request you to spend a lot of time doing exploration of the data. And these are certain techniques like, box plot, line chart, certain simple techniques like, in Excel, how we have sort of looked at the product wise sales for April, May, and June here, right? Next, basically, we have done some bar chart, but I'll take you to what I wanted to study, what I wanted to show you today, right? Can you see this table, everybody? Are you able to see this? Are you able to see
Yes,
this?
sir.
Okay, so this is what is market basket analysis, which is what I want to talk about. See, in the case of market basket analysis, when we have done this, you have LHS, RHS. This is the heading. Then you have certain measures called as support, confidence, lift. In the LHS, you have
Sir,
butter and yogurt.
I apologize for see your PPT, sir.
Sir, what happened, sir?
I couldn't able to see. I cannot able to see your PowerPoint, sir. I am just seeing your Excel sheet shared on the screen.
Okay, let me just.
I don't know about with others, sir.
And we are also able to see the Excel sheet.
No, I've moved to. This is the PowerPoint.
This is a PowerPoint. Now we are able to see PowerPoint. Yeah.
Okay.
Correct.
Earlier,
Correct.
I was just doing all these slides and all.
Okay. Yeah.
Okay, that's okay. It's okay. We can just focus on this particular slide. Can you see this slide?
Yes.
Okay, so what exactly is market basket analysis and how have we used a priori? So yesterday you learned decision tree. Today we'll be learning a technique which is called as a priori. A priori is used for product associations. So in the data set, when we try to identify which products sell best with which other item, look at this, you have LHS, left-hand side, and RHS. So what the algorithm has done is basically, this is the output of the algorithm that I'm showing you. This is the output. Out of all the items, what it has done is basically, it says that butter and yogurt, if a person has already purchased butter and yogurt, there's a good chance that he buys what is called as whole milk. There is a very good chance that he buys whole milk. So whole milk can be cross-sold to a person who has already purchased butter and yogurt. So given that a customer has purchased butter and yogurt, you can sell whole milk. Similarly, curd and yogurt, again, if a person has purchased this, you can cross-sell him whole milk. So RHS are those items which can be cross-sold to those people who have already purchased LHS. Next, you have tropical fruit and yogurt, right? So you have whole milk here. Whole milk can be cross-sold to these guys here. Correct? So these are the product associations which tend to go very, very well together. These are the product associations which tend to go very, very well together. Now, this is what is the meaning of this? Let us look at what is called a support here. Support means basically support is actually pointing towards the LHS. In your entire data set, basically, if you move the decimal 2 digits to the right side, 0.9, which means almost 0.9%, almost 1%. In the entire data set, almost 1% of the customers have purchased butter and yogurt. That is what it means. 1% of the customers have purchased butter and yogurt. Look at the confidence. How confident are you that a person who has already purchased butter and yogurt is going to buy whole milk? The answer is 63%. So if you sell whole milk to a person who has already purchased butter and yogurt, there's a 63% chance that he's going to buy whole milk. Next, what you have is basically lift. This is a very, very important metric. It is 2.5. The lift value here is 2.5 or 2.5. Now, lift value can be from 0 to infinity. Value which is greater than 1 is what we usually look at. So if the lift value is greater than 1, what does this mean? So here the lift value is 2.5. 2.5 means if you are selling whole milk to a customer who has already purchased butter and yogurt. So in other words, let me just say this again. A person who has purchased butter and yogurt already is 2.5 times more likely to respond to whole milk as compared to a customer who has not purchased butter and yogurt. Is this clear? Are you able to understand? Hello?
Yes,
Hello?
yes, please. Hello, hello.
Yes. Are you able to hear and understand this?
Yeah, sir,
Just
please repeat once. Yes, sir.
yes. So just saying that there are many products. All right. If you have 10,000 products in a retail market, you may not understand which item should be cross-sold with which other item. I should pair up which two items. Because why should I pair up? Otherwise, the customer will buy one item and go. If instead of selling just one item to the customer, I, as a businessman, I'm thinking like a businessman now. Instead of selling just one item, I want to sell two items to a person who has purchased one item only. So if a person is buying two items, I want to sell more, 3 or 4 items. If a person is purchasing four, I want to sell 6 or 7 items to him. How do I do that? That is the entire question. So the entire question, if you look at this, a person who has purchased butter and yogurt implies whole milk, which means that if you want to sell whole milk, whom should you target? Sell it to a person who has already purchased butter and yogurt. How do I know? A priori algorithm does a deep dive analysis at the back end and it reports this finding. Person buying butter and yogurt is likely to buy whole milk. Similarly, a person who has already bought curd and yogurt also buys whole milk. If your question is to whom should I sell whole milk? Very important question. I have certain products. I want to know to whom should I sell this. I have whole milk. To whom should I sell this? A priori algorithm can be used to answer this question because a priori says that you can sell whole milk to those people who have already purchased butter and yogurt or root vegetables and yogurt or yogurt, whipped cream and such things. So this is your best set of customers. Now, similarly, if you look at the right hand side, RHS means right hand side. Other vegetables, to whom should I sell other vegetables? Sell it to a person who has already purchased root vegetables and yogurt. Or if a person has bought yogurt and a sour cream, you can sell him other vegetables. So this is how basically you can sort of cross sell one item with another item. If you look down here, you have whole milk and yogurt. So given that a person has purchased whole milk and yogurt, you can basically sell root vegetables to him. This is what it means when we say cross-selling one item with another item. Now there are certain metrics. Now, just as in the case of linear regression, you looked at R square, you looked at certain other metrics as well. Here, in the case of a priori, you do not get any R square and such things. There is no dependent variable here. You don't have any dependent variable. There is nothing here. So you can't call this a supervised learning technique. Now, all that you're getting is basically, it is just looking at something like a Venn diagram, right? Two items, how many people have purchased. So there are three important metrics. One is what is called as support. Second is what is called as confidence. And the third one is what is called as lift. By looking at these three metrics, you can tell whether the relationship is strong or weak. How can I tell this? Look at the support value here. Support is already always pointing towards the LHS. In the entire data set, if you have a sample size of 1,000 customers, support is 0.009 here, which means 0.009 means basically less than 1% this is. So less than 1% of the customers have purchased butter and yogurt. That's what it's selling, correct? We don't want to cross-sell an item to those people who have bought merely 10, let's say only 10 customers have purchased a product. Now I can't, out of 10 persons who have purchased butter and yogurt, maybe 8 have bought whole milk. Now 10 is not a good number at all. 10 is a very weak number. You can't trust a result based on just 10 individuals' propensity. So what we are saying is basically support becomes very, very important because it tells you in the entire data set how many people have bought the first item. When I say first item, this is called as LHS, or some people call this as antecedent. What has happened first? It is something like cause and effect. It is something like cause and effect. If it rains, then I take an umbrella, right? If it rains is the first part, then what is the action? What is the consequence? Then you take an umbrella, right? If it rains, I will get wet. So if this happens, then something happens. The same way here, if LHS happens, then RHS happens. If you buy butter and yogurt, you tend to buy whole milk. If a customer buys curd and yogurt, you tend to buy whole milk. If you buy pip fruit and yogurt, you tend to buy whole milk. Now, let's look at the if part. How many people have bought butter and yogurt? Less than 1% of people have bought butter and yogurt, right? How do I know? Look at the support here, 0.009. Move the decimal 2 digits to the right side. It is 0.9, which is less than 1%, which means basically less 1%, approximately 1% of the people have bought butter and yogurt. Now, what is the confidence that with which you can say that whole milk can be cross-sold to people who have bought butter and yogurt? 63% is the confidence level with which you can say that people who have purchased butter and yogurt are likely to buy whole milk. So that's how you can talk about confidence. Then you have a measure which is called as lift. Lift value is 2.5. I repeat, lift value is 2.5. What does this 2.5 mean? 2.5 means basically, let us say there are two customers, John and Matthew. I'm just giving an example. John and Matthew are two customers. My question is, should I sell an item to John or should I sell an item to Matthew? Should I sell whole milk to John or should I sell it to Matthew? Now, let me give you an additional piece of information. John has purchased butter and yogurt, which means in his basket, there is already butter and yogurt. While Matthew has not purchased butter and yogurt. My question is, to whom should I sell whole milk to? Should I sell whole milk to John or should I sell it to Matthew? Remember, John has already purchased butter and yogurt. Matthew has not purchased butter and yogurt. So when you look at lift, what does it number? 2.5, 2.5. So which means that John, who has already purchased butter and yogurt, is 2.5 times more likely to respond to whole milk as compared to a customer like Matthew, who has not purchased butter and yogurt. John is 2.5 times more likely to respond, and therefore John is the person whom you should reach out to, whom you should approach for butter and for whole milk. You better don't reach out to Matthew. That is how you need to interpret lift value. So I'm just talking about lift here. Is this clear?
Yes,
Yes, sir.
Yes.
it's clear. Yes, sir. Yeah.
Okay. Now, what I'm going to do is basically, I don't want to, there is not much of theory and a strong this thing. It's just commonsensical, as I said. I'll just close this and open up an Excel sheet. Please tell me if you're able to see this Excel sheet.
Yes, we are able to see.
Now, there are many variables here like card ID, value, payment method, gender, homeowner, and income. I can't use any of these variables for analysis. I can't use any of these variables for a priori algorithm and such things, because these are all demographic details and payment details, and maybe you also have his age and such things. Right? You also have his age, so I can't use any of these things. Let me scroll to the right side. Now you can see all the products. Like there are many products here, like fruit veg, right? And fresh meat, dairy products, canned veg, canned meat, frozen meat, beer, wine, soft drink, fish, confectionery, right? And this is like a truth table, because if I apply a filter here, if I just put all DFF, right, you can just see here for each product, it is either F or T. F means false. So the first person has not purchased fruit veg, but he has purchased fresh meat, dairy, and that's it, nothing else. The rest of the things are F. Second guy, he has purchased fresh meat, but the rest of the items are nothing. You see, F, F, which means that he is a good candidate for cross-selling item. Oh, he has also purchased confectionery, sorry, correct? So if now, what are the product association? Which item can be cross-sold with which other item, right? That is the question here. Now, when I look at this sample size here, at the sample size here, the sample size is approximately 1000. So it's a good case for us to build market basket analysis here. We can do market basket analysis in here, right? How do we build market basket analysis for this data set? That is the entire question. Is the data set clear?
Yes.
Hello, are you able to see the data set?
Uh, yes, we are able to see.
So this is the place where you have. So we are just going to look at products. We're not going to look at much. We are just going to look at products, and we are going to look at product associations here. Don't take demographic details and such things. And when you have this kind of a data, it's called as a truth table. So the base data should be a truth table for you to do a priori analysis. So I'm going to work on this data set. Now, can you tell just by looking at it which item can be cross-sold with which other item? Is there a possibility? No, right? We can't look at the data and say anything. Am I right? We can't just
Yes,
look at the
we are
data. Yesterday also in defaulters and such things, by looking at the data, we can't do anything. Therefore, we
correct.
need an algorithm which can put life into the data. Data, remember, is just a fact table. Fact table means it just has facts and figures. There is nothing else. I can't make any head and tail of this. If I take a printout, that will be a long rolling printout, that lengthy, long roll, that long rolling printout, wherein you can just go on printing numbers. That is basically lifeless data. It does not have any life. It does not tell me much. My question is, when you're an AI guy or machine learning, never be carried away with the algorithms and such things. Ask yourself a question: what is the story that the data set is telling me? Is there a story in that data set? Are there any insights? Can I go back to the business and say, boss, if you invest here, your life will be better. If you invest there, you'll make a mistake. If this product can be cross-sold best with that product. If you target him, he's going to be a fraud. If you target this fellow, he's going to be a genuine customer. Your housing prices are cheaper in a particular locality. It is more expensive in other locality. That story telling is also very, very important when you're an AI or a ML person. Never run behind algorithms. Algorithms are important. I'm not saying algorithms are not important. So there is a saying in our world, in the world of data science, there is a saying. We say that all models are wrong. Every model that you build in your career is wrong by default. Take it for granted that it is wrong. It's just that some models are useful. All models are wrong. Just that some models are useful. It may help us to solve many problems. That's why in the industry, when we build many models, 80% of the models are not adopted at all. 80% of the models are not adopted. They don't see daylight at all. Maybe 10% or 15% here or there, which are useful, will be adopted by the industry. Correct? So useful in the sense it should solve a problem. So what is the problem that we are trying to solve? We are trying to find out product associations. So to show this, I will use a tool which is called as IBM Modeler. Then I will execute the same thing in R and show you. Here you can see here, there are 12 products. There are merely 12 products. So when you have, sorry, 11 products. So when you have these 11 products, what are the product associations? That's what I want to show you first. Let me just show you a tool. So this is a tool. Please tell me if you can see the tool. This is again an IBM tool, right? Yesterday we saw IBM SPSS. This is a sister software of IBM SPSS. It's called as IBM SPSS Modeler.
Yes, we are able to see it.
It is just coming up.
Yeah.
Yesterday's tool was, GUI based, right? You could just point and click.
You are not audible, Mithun.
It's a Excel. Now this data sets like databases like SQL, WAR file, fixed file, anything.
Mithun, you were lost in between. We could not hear you. So will you please repeat it, whatever you said?
Yeah, so I'm just saying that this is a tool which is drag and drop. So if you have to load the data set, how do you load the data set in this tool? That's what I'm showing, right? So I'm
Okay.
just going to sources. And do you see this icon which is called as var file, VAR? Are you able to see this icon?
Uh,
Are you able to see this?
where it is, yeah. Now, okay, now we are
Yeah, this is the tool, var file here at the bottom.
at the
I'm moving the
bottom.
cursor.
Yeah, yes. We are able to see that. Yes.
Yes, so you can see here, read data from a text CSV file. So let me
Correct.
just double click. I want to import the file. The moment I double click, that icon comes here. So again, double click, that icon will open up. Now in the file, I have to just specify the path of the file. Where is the file it is asking me? So let me just go to program. Let me just go to C drive, program files, IBM, SPSS. Then I can go to modeler. I'm just giving the source file 18.0, and then basically some, then basically demos. And here, basically what I can do is I can just look at my file. So the name of the file is basket1, and this is the source file. I hope you can see the preview of the file here, right? This is the same file which we were working on. Do you agree? It is just giving you 10 records. Can you see this?
Yes.
So I have imported this data set. You
Okay.
can import this data set. I'll just click on OK.
Okay.
Now, right, this file is loaded. Let's say I have to display this. How do you display a file in IBM Modeler? So just go to field options and type the type node. So this type node, if I just double click, right, it will display all the variable names in the data set. Can you see this? These are all the variable names. Are you able to see this?
Yes.
So from fruit veg, fruit meat, fresh meat, dairy, canned veg, canned meat, frozen meal, beer, wine, soft drink, fish, and confectionery. These variables, I'll just call them as flag. Flag means basically there are only two possible outcomes, true or false. Correct? So here, by default, the model will treat it as input variable, but this is not input. It is not independent variable. Neither it is dependent variable. So when the variable is neither dependent or independent, here you have to choose the direction as both, which means it is neither input nor output. It is not a supervised learning model that we are building, right? In the case of linear regression, we were predicting housing price. Therefore, that was the target variable. Here, this is not a supervised learning technique. We are just trying to find out relationship between two products. So treat the relationship, treat the direction as both. Don't specify it as input or output. Is this clear so far?
Yes.
I'll just click on OK here. That's it. Then this is the field options here. Now you can just go to output palette. This is called as palette. It's like a menu itself. I'll just click on table. You can see here there is a stream. You load the data, specify the variable type, and then basically you can just execute the table. Are you able to see this? So this is the entire data set that we have. Are you able to get this?
Yes, yes.
So I have loaded this data and this is basically the display of the table. Okay, so what? Now let us do a bit of EDA or exploratory data analysis. So in modeler, why am I showing this? Because this table, this chart which I'm going to talk about is present only in IBM modeler. It is not present in other tools. So I just wanted to make use of this so that you understand this clearly. I can go to what is called as graphs and then basically uh, visualize the relationship. How to visualize the relationship? You can see here there's a special type of graph which is called as web chart. This is what is called as web chart. It is not like your scatter plot or something. It's just a web chart. It is putting a question mark because it is not able to understand the variables. Okay, not a problem. Let me just import all the product related details here. See here, you have fruit veg, fresh meat, dairy products, all these products. I'll just click on apply and then say okay. So these are the variables which will be included for analysis. These are the variables which will be included for analysis. You can just say, show me the relationship between true flags and then go ahead and run this model. Are you able to see this?
Yes, we are able to see.
Look at how beautifully it is showing you. All the products are in the periphery. I hope you can see all the products here. And then basically it has created lines between each of the products here. Correct?
Correct.
Thicker the line. Some of these lines are thick. Some of these lines are thin. So thicker the line, stronger the relation. Thinner the line, weaker the relation. That is the simple thumb rule. So can you see some thick blue lines?
Correct.
And some thin blue lines?
Yes.
And you can see a scroll bar here.
True.
Let me just increase the scroll bar, move the scroll bar to the right side. Are you able to understand see the thicker bar clearly?
Yes.
Now, what does this mean? Look at this. Canned veg, frozen meal, and beer have a strong relationship. That's what it means. So, if I bring the cursor here, it means that 173 people who have purchased canned veg also buy frozen meal. Are you able to understand this?
Yes.
Similarly here, frozen meal and beer have a strong relationship because 170 people have purchased this. If I bring the cursor here, it means that canned veg and beer also people tend to buy together because 167 such people have bought these two items. And then confectionery and wine items sell very well together. Fruit, veg, and fish also sells very, very well together. Is it clear?
Yes.
So let me just click on this arrow here. To the right side, are you able to see this now? Are you able to see this table here?
Yeah, we are able to see.
So you can see many product associations here, correct? Canned veg and frozen meal, 173 links or associations are there. Frozen meal and beer, many associations are there. Canned veg and beer, many relations are there, right? And similarly, fruit veg and fish, 145 people are there. So you can see here, it reads strong links. So if you want to sell any of these products, look at the strong links. If I scroll down, what you can see is basically medium links. See, medium links heading. Only 35 people have bought dairy products and soft drink. Frozen meat and dairy products, 33 people have bought. Dairy and canned meat, basically 31 products have bought. Weak links it is not showing because there are not too many weak associations. So this is how the associations can be classified as strong, medium, and weak. This is a very high level exploratory technique. So far, is it clear?
Yes, yeah. So this is an
Uh,
IBM. Okay, the tool is from IBM, isn't it?
yes, this is a tool from IBM Modeler. I'll show something similar in R also today,
Okay, okay, okay.
how it differs, but it's a lot easier because I can save the time and such things, and there are, yeah, easy customized features.
Right, right.
Now comes the main thing, the algorithm. What is the algorithm to find out product associations? As I told you, there is an algorithm which is called as a priori algorithm. So how to execute it? Go to modeling. Here you can do classification, you can do association, and therefore you can do what is called as a priori. The very first technique is what is called as a priori. You can see here there are 11 fields which it has understood, and let me just click on run. Can you see the output is coming here, right? The output is basically shown. Right click and just choose browse. Are you able to see this?
Yes.
So here what I'll do is basically, let me just say display all. Okay. So firstly, there are certain things called as consequent and antecedent. Antecedent means what? A person who has already purchased. Antecedent means what happens first. If this happens, then something will happen. So if part is the first thing. If a person has purchased beer, frozen meal, uh, okay, there is a wrong variable here, gender. Gender is not a product. So this is a mistake which I have made. This product should not be, this variable should not be taken at all. So let me just go back and correct this mistake. I have to go to type. So fruit and veg is fine. These are products, that's fine. Okay. Others, basically, I have to change the relationship. I have to specify the relationship of some of the other variables as none. None means don't use these variables at all, right? Card ID is nothing but your record ID. So gender will not be taken for finding out product associations. Let me now look at, are you able to see this now?
Yes.
So look at this. If a person buys beer and canned veg, there is a good chance that he buys frozen meat. Correct? Look at the support here. 16.7. 16.7 means basically out of 1,000 people, 1,000 customers, 16% of people have bought frozen meal. Okay. Now, what is the confidence rule here? 87% of, you can be 87% confident that people who buy beer and veg, canned veg, are going to buy frozen meat. Now, the lift value here is what is called as 2.8. If you round it off to 3, it means that people who have already bought beer and canned veg, they're 3 times more likely to buy frozen meal as compared to a person who has not bought these two items. Similarly, you can see there is some association between beer, frozen meal, and canned veg. And yeah, these are the 3 items which are coming out clearly. Are you able to understand this?
Yes.
So this is one way of looking at it. Sorry. Now, let me just open up the chart here, web chart. What I'm going to do is I am going to just select some of these strong associations. Like let's say canned veg and uh, frozen meal. How many people have bought? Let's say 173. Let me right click and create a new variable wherein wherein customers have bought both these items. That is, people have bought both canned veg and frozen meat. Right? I've just right clicked and created a node. You can see here there is a different icon that is appearing here. So here, just see, I'm going to connect the node. I'm going to connect the node. and then show you in the table what it is, what is happening. So this is our data set. Can you see T underscore T? In the end, there is a new variable that is created, T underscore T. This is the variable that we have created now. Can you see this, please?
Can you put the cursor on there? Yeah.
Yeah, here. Are you able to get this?
No, we are not able to see the cursor.
Yes, this is the data set which I was just showing you.
Okay, okay.
So in the end, we had how many products? 11 products. Now we have created one more variable, which is again a flag. F means basically those people who have not, F means false, T means true. So we have created an indicator variable false and true. True means basically people who have bought those two items. You can see here, people who have bought both canned veg as well as your frozen meal are marked as true here. And people who have not bought these two product combinations are marked as flag. Are you able to understand this?
Yes.
So false means basically the first customer has not bought canned veg and frozen meal, F and F. So it will again create F here. Second customer is marked as FY because he has not purchased frozen canned veg and frozen meal. Third fellow has been marked as T. Why? Because he has bought both these items, canned veg as well as frozen meal. So wherever both these variables are marked as true, that is a person has purchased both these items, then my final resulting variable will also be true. Why? Because I want to understand the profile of those people who have purchased canned veg and frozen meal. That is the goal here. What is the profile of those people who have bought those two items here? That is the next stage of the analysis which I want to do. Is this clear? Is this clear?
Please repeat it once, sir.
This is T and this is T.
Yes.
T and T means what? The third customer has bought canned veg and frozen meal. Do you agree?
Correct.
If a person has bought both these items, I am creating a new variable which is called as T, which means that the third fellow has bought both canned veg and frozen meal.
Yes.
Correct?
Correct. Correct.
Now, there are many instances wherein it is marked as F. F means the person has not bought one of these two items. Both these items he has not bought. Now, let me just take a look at this. Can you see here? There's a T here, correct?
Yes.
So look at his behavior. He has purchased canned veg as well as frozen meal. Both are T. Therefore, the resultant variable is also T. We want to select only, we are selecting only those people who have purchased both these products, canned veg and frozen meat.
Yes.
Okay. Now,
Right.
what is the use of this? The next stage is basically, I want to identify the profile of these people who have bought both these products. So yesterday we had learned decision tree.
Correct.
So now I'll just be applying a decision tree. How? Modeling, I'll go to classification here. And here there is what is called as cart. Yesterday we have learned cart. Can anybody tell me what is cart? What is cart? Classification and regression tree, isn't it?
Yes.
Right? So let
Right.
me just click on cart here. Now what I will do is basically The target variable is what? The last variable which we had built. So we have built this variable. Okay. Let me create one more type variable. Take it here. Now look at this, which is the target variable. This last variable, I have to change the direction to target. Now products are not needed, so I'll change the direction to none. Demographic details like value, promotion method, gender, homeowner, and income, we can make this as input variable. Right? So we are predicting the profile of those people who have bought both these items, confectionery as well, canned veg, and one is basically canned veg and the second one is frozen meal based on his demographic details. Okay, let me just go ahead and execute this. Cart model is ready. Right click and just choose browse. So are you able to see this, everybody?
Yes.
Yes,
Now
sir.
when you see, yes. So what is the profile of those people who have bought these items? Look at the key drivers: income, gender, promotion method, and value. These are the 4 drivers which influences a person buying both items. So here, if you can see here, if the income level of a person is less than 16,900, then, right, it implies F, which means they have not bought. On the other hand, if the income level is greater than 16,900, it means it is F again, which means people have not bought. Let me just execute this. Income is less than 16,900 and the gender is female, which implies F, which means that people have not purchased. So females with an income of 16,900 have not bought frozen meal and canned veg. On the other hand, males whose income is less than 16,900, they have purchased this particular item. Therefore, it is being shown as T. What happens when the income is greater than 16,900? It is always false. Always false means they have never bought these 2 items. So how do you identify whom to cross sell? Right? Look at males whose income is less than 16,900 because these are the people who tend to buy frozen meal and canned veg. This is what your decision tree algorithm says. So first we used a priori, and based on that we were able to construct the decision tree. So far, are you clear?
Yes.
Any questions?
I think questions will ask after sometimes when. Yeah.
Okay.
Yeah.
Okay.
As of now, no questions yet.
Okay. Now what I'll do is I'll try to show how we can do this through coding. Right now, this is just at a very high level. I just showed you how a priori algorithm and works. I'll just close all these things. What I'll do is I'll just show how a priori works in R. Using R, I just want to show you how this a priori works. Right? Some amount of coding is there in R because it is not so easy as in IBM modeler. So please tell me if you're able to see my screen.
Yes.
Right, I'm again going to do product associations itself, but now I'm going to take a larger data set. Not 12 products, we'll be just taking a slightly bigger data set. Okay, now what are some of the first things that I need to do? Let me just freeze the screen properly. Are you able to see this here?
Yes, we are able to see. Yeah.
Okay, let us just try to execute a priori algorithm here. Firstly, we need to install certain packages here. correct? First package that we need to install is what is called as A rules. A rules means association rules, right? Association rules. Okay. Package was built under R version 4.1.3. So A rules, when they built the package, R version was 4.1.3. Okay. Now we'll try to visualize this A rules visualization. Okay, some warning messages are being shown. Don't worry about this. So now what we will do is basically we will just try to install some of the packages like A rules Viz, and color space. Next thing that I like to do is basically use a inbuilt data set. So this data set is called as groceries data set. I hope you can see here data of groceries. This is an inbuilt data set which is given by R itself. R itself provides this particular data set. Now, what I'm going to do is basically I will assign this groceries data set to an object which is called as transaction. I'm just giving the name to transaction. That's what I'm doing. Firstly, I will be running the summary command on this file, summary function. So you can see here, are you able to see certain product associations here?
Yes.
Before this, let me just at least show you the data set firstly. I'm sorry. View of I'm just trying to show you the data set here. Okay, GROC and just write it as it is. It is just showing you there are in this file groceries you have 9,835 transactions and 169 items or products. 169 products and there are approximately 9,835 transactions. Now I'm just going to run a summary function, right, of transactions. You can see here some of the popular products which are coming out. Can you see here most frequent items are whole milk, 2,513 uh, times people have bought whole milk, which means 2,500 divided by by around 10,000, 9,000. I'm just rounding it off to 10,000. So 2,500 divided by 10,000 is almost 1 by 4, which means 1 out of every 4 customer is buying whole milk. Then you look at other vegetables, it's almost 1,903. If you round it off, it becomes around, let's say 2,000. 2,000 divided by 10,000 is 1 by 5, roughly, which means 1 out of 5 customers are buying other vegetables. Rolls and buns, 1,800 customers are buying. Soda, 1,715 people are buying soda. And 1,372 people are buying yogurt. And the rest of the items, 34,000 people have bought this. So from this, I can answer the first question, which is the most popular item that people buy, whole milk, followed by other vegetables, followed by rolls and buns. These are the 3 most important items that people buy. So far, is it clear?
Yes.
Nextly, when you say summary here, look at the size here. 2,159 people buy only one item. 1,643 buy 2 items. 1,299 people buy 3 items, so on and so forth. Now, there is one customer who has purchased 32 items. Maybe he's buying for an entire month. I don't know. He has purchased 32 items here. Are you able to understand this?
Yes.
Which means bulk of the customers are buying only one item. Okay, let me just go further. Let me look at the sample size or n row, right? So in R, there is a command which is called as n row. And when I just hit enter, you can see here 9,835 is the sample size here. 9,835 is the sample size here. Is this clear?
Yes.
Okay, that's okay. View. Okay. Now, what I want to do is basically construct a what is called as an item frequency plot. So I'm just running this command, item frequency plot of transactions. Transactions is nothing but my data set. Minimum support is 10% I'm giving, right? I can play around with this number. It's entirely under my control. So when I run this, you can see here which are the most important items graphically, correct? You can see here whole milk, other vegetables, root vegetables, tropical fruit. These are the most important items. But primarily whole milk is the one which is appearing here. If 25% of the people are have bought whole milk. So far, is it clear?
Yes.
So you can just change the settings here, right? So you can recall this command. You can just put a color here as 2. You can see here you have a more appealing graph. You can use this graph
Yes.
for analysis, right? Now, one other thing that you can do here is, so based on the relative frequency, you can show the chart. The second thing that you can do is you can also construct a plot, item frequency plot here, wherein you can just see, tell me what is the difference here. What is the difference here? Earlier, I had given minimum of 10%, which means only those items which have been purchased at least 10% of the times will be shown. Here I'm saying 5%, which means basically at least 5% of the times they have purchased here. So this is, you're no wonder getting more number of bars here, indicating that there are more items which have been purchased more than 5% of the times. Is this clear?
Yes.
Okay, so when you have so many items, it is better instead of using a vertical bar chart, you can just say horizontal equals true, and you'll be able to get the same display in this fashion. So it's a lot easier to see which are the items which are coming at the top, which are the items which are coming at the bottom, right? So if you want to make a PowerPoint presentation and all, just use the same code, but say color equals, let's say 3. Now I think you can just change the color by just, this is a lot easier to interpret. It's a lot easier to take it and publish in graph and such things. So here what we have done is basically a high level analysis of the data set that we have. Now let me just go deeper into this. Let us say I want to display only the top 20 items. Top 20 items which are getting sold the best. You can see here only the top 20 items will be displayed here. Only the top 20 items. Most popular items in this organization. So far, is it clear?
Yes.
Correct. Now, next is basically, after this exploratory data analysis, the next thing that we want to do is basically, you can just change this from top 20 to top 10, however you want, right? Top n equals 10. You have to just play with this number and you'll be able to get the top 10 items here, like whole milk, other vegetables, and rolls of buns. This is what you'll be able to get. And based on the frequency, you'll be able to see the distribution of the top 10 or the top 5 items. So what we have done is basically simple exploratory data analysis, nothing more. We have not done anything beyond that. Now what we'll be doing is basically, we will be running the a priori algorithm. How to run the a priori algorithm? Just run a priori function. Just run the a priori command on groceries, and within this parameter, you can just specify the parameter list. Within this parameter, you can just specify the parameter list, and you can give the minimum length as 2 here, which means at least 2 times this product must have appeared. Are you able to understand this clearly? Are you able to understand this? So it is
Please,
not giving, it is just
please
giving you
repeat
some minimal
once.
output. Sorry.
Um, please repeat once. Yes.
Yes. So I've run the a priori command on the dataset groceries, and I've saved the results as rules now. Now it is just giving basic information. It is not very helpful. Now what I'd like to do here is I would like to run a summary command on the rules. I've run the a priori command, as you can see here, a priori, and I've saved the rules object as rules. Now let me just run the summary command on this object. Summary of rules. Can you see here
Yes.
what it is showing you? So it has extracted 224 rules, not one, not two, but 224 rules have been extracted. You can see that 111 customers have bought 2 items, 113 customers have bought 3 items. Is this clear? Minimum
Yes.
number of items that have been bought is 2, right? Minimum is 2. On an average, people are purchasing around 3 items. That is what it is basically telling me, correct? So this is at a very high level. It is just giving me the summary of the purchase pattern. Now, let me just some of the important rules. Let us just examine, right? The top 5 rules is what I would like to examine. So I'm just going to run an inspect command and say sort by support and then by confidence. Now you can see which are the most are occurring items here. Butter and yogurt leads to whole milk. That's what it says. Support is 0.9%, confidence is 63%, coverage is 0.01, lift is 2.5, and then the count is 92. So far, are you able to understand? Similarly, if a person buys citrus fruit and root vegetables, he can be expected to buy other vegetables. Tropical fruit and root vegetables, that leads to other vegetables. Curd and yogurt leads to whole milk. Other vegetables and curd also leads to whole milk. Is this clear so far?
Yes.
Now, let us just understand one question. Our aim now, going forward, what is our aim? Our analysis was aimed to see what makes people buy milk, right? What products exactly lead to a person purchasing milk? To do so, we should choose the subset of the rules which has whole milk or soda in the right hand side. Now, if you see the right hand side, which all products you have, whole milk, other vegetables, whole milk, and it can go on. Because I've said only 1 up to 5. I can just change it to 1 up to 10. You'll get 10 rules here. You can see here, there are 10 rules here. It is also showing you a relationship between whole milk, so on and so forth. Whole milk, other vegetables. These are some of the items that are present in the RHS. But I'm not interested in every other item in RHS. Let's say I'm interested in only one specific item, which is whole milk, right? So if from 223 rules, if I want to just fix only whole milk, how do I do that? To do that, let me clear the screen here by pressing Control L. Now, what I'm going to do is basically from the extracted rules, I will be fixing. You can see here RHS percentage in percentage whole milk. I am limiting my analysis only to whole milk, right? So you can see here sort subset. From the you take a subset of rules which has in the RHS only whole milk and create what is called as milk dot rules. Now we can examine which of these rules is actually significant. Are you able to see, is it significant? Which means basically we are looking at the p value. If it is true here, it means that all the rules are significant. But you can see here some of the rules it's marked as false, false. The last 3 rules are marked as false, indicating that these rules are insignificant, which means we cannot take them seriously. Sir, show me the rules. Let me show you the rules. Which are those rules? I'll just show you. Inspect. I have to just type inspect of milk dot rules. You can see here when I say inspect of milk dot rules, I am getting all the rules. What is interesting here is basically I am able to fix my RHS as whole milk. Whole milk, my product. See, usually what happens is that you may not be wanting to sell every item. There is one product which is selling the least, or let us say there is one product which you want to push into the market. You want to identify, let's say there is a new product which you want to sell to existing customers. So you're interested in understanding what makes a person buy whole milk. You can see the reasons in the LHS. If a person buys butter and yogurt, likely to buy whole milk. If a person buys curd and yogurt, likely to buy whole milk. Other vegetables and butter, likely to buy whole milk, so on and so forth. So you can basically fix the RHS. That's what I'm saying. You can see here, instead of looking at every rule, fix the RHS as only whole milk. That is what we are doing here. Is this clear?
Yes.
So we have fixed rules only for whole milk. Now, just as we have fixed rules for whole milk, even before looking at this, what is the inference? It turns out that most popular baskets are what? Curd, yogurt, or fruits and vegetables. Seems like the most popular 1 week ahead groceries we do. People, if you have to buy basically for 1 week groceries, you have to buy, people are buying curds, yogurt, they're buying fruits and vegetables. Right? Sir, instead of a whole milk, can we do the same thing for Coke? Right? Coke rules, you can just see here. Right? Here I'm fixing the RHS as basically soda. Right? Fixing the RHS as soda. Now again, you can inspect all the product associations with Coke rules. You can see here, when does a person buy soda? Sausage and rolls, if he buys soda. Chocolate leads to soda, dessert leads to soda, bottled water leads to soda, sausage leads to soda again, fruit and vegetable juice also leads to soda. So far, is it clear?
Yes.
Right? If you want to examine out of this, which is a significant rule, not every item is significant. Is not significant. There are 5 rules. All of them are true, 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 which means that every rule is significant and therefore you can take it seriously. If it is false, it means basically that you don't need to take it seriously. Let me plot these rules. I'm just doing a simple plot rules for Coke rules. Are you able to see anything here? Y-axis we are taking confidence, x-axis we are taking support. The 6, there are tiny specks of dot. I don't know whether you are able to see this here. Very tiny dots here. Can you see here?
Yes. Yes.
So
yes.
here it is marking as lift, which means basically deeper the red color, stronger is the higher the lift. Lighter the red color, weaker is the lift. That's what it means. Are you clear with this?
Yes. But it's difficult to make it, whether it is a dark or it is because the dot is very tiny.
Yes, which means it is light color.
Yeah. Yeah.
Light means light lift. You know, ideally speaking, where should the rules be? Not here. The dot should be here.
Yes.
If it's at the top right hand side corner, it means what? High support it has, high confidence it has, high lift it has.
Yes.
Here I'm not able to see one single rule, which means that most of our rules that we have extracted have a weak support, but a reasonably high confidence and higher lift. That's what it means for Coke. Because I'm seeing the rules, one is here, second dot is somewhere here, right? So the third ones are basically not visible because the lift value is very, very low. It is dull, and therefore we don't need to take it seriously.
Yes.
So far, is it clear?
Yes.
Right? Secondly, I like to now move on to meat rules. Okay. Now we'll be looking at the rules for meat. Now, what I'm doing here is basically I am looking at LHS. Now I'm fixing the LHS. Earlier, what I had done was basically fixing the RHS. Now, basically, I'm fixing the LHS and I'm saying percentage in percentage beef or sausage. If a person has purchased basically beef or sausage or chicken. Are you able to understand?
Yes.
Now, I'll just be typing inspect of meat dot rules. So when I click on inspect of meat dot rules, you can see here the 3 items which are of our interest. Given that a person has purchased meat items, like it could be chicken or beef or any of these items, what is the next best buy? What is it that he's buying next? Then basically you can look at the RHS. If he purchases these things, he's likely to buy whole milk. If he purchases chicken, he's likely to buy other vegetables. If he purchases beef, he's likely to buy whole milk. If he purchases beef, again, he's likely to buy other vegetables. Is this clear?
Yes.
So far, is it clear to others?
Yes. Others can, yeah, confirm whether Dr. Ravindra, you can just, or anyone else who is there.
So far, is it clear?
Yes, yes, it is clear. Well,
If you want to
Mahimba,
see next best buy, fix LHS. You'll understand which is the next item that the customer is going to buy. If you want to identify cross-selling opportunities, fix RHS.
okay.
The rest of the things are pretty simple, support, confidence, lift, and such things. Okay, now we can just inspect meet rules. These are basically okay. These are some of the rules that we are getting. Okay. Now let's just make a move on to certain interactive charts. Let us plot these. We're plotting the Koch rules. Method is equal to graph, right? Are you able to see this?
Yes, we are able to see the
Distribution of the different products, correct? And a few red dots, correct?
correct.
It is not very helpful. So what I'll do now is basically, right, while plotting this, I'll change interactive equals true. Right, I'll just make it as true. Are you able to understand? We are looking at those products which lead to soda.
Okay.
Like chocolate, dessert, rolls and buns, sausage, other bottled water, and basically vegetable juice. Sorry, fruit juice or vegetable juice. Basically, all these items, when people buy, it leads to soda. That's what it means.
Yes.
If the green circle is bigger, it means support is higher. And if the pink circle is deeper in color, it means that the lift is higher. Is this clear?
We are not able to see the circle. Yeah, that is the rule we understood. But then the screen is showing is
Green
it's a,
is for support and red is for lift value.
no, but the screen is showing blank. Yeah, it's
Blank.
yes. Now we can see. Yes, now we are able to see the green and the red. Yes,
So I hope this is clear, right?
right.
All the items are at the periphery are basically your RHS. And if you look at the direction of the arrow, since it is pointing towards soda, it means that people buying any of these items tend to buy soda.
Correct.
Okay. Let me just close this, come back to my code. This is my code window. Now for yogurt, let us just do the same thing. This is, we are just looking at the rules for yogurt. And then we'll just quickly plot for yogurt. Okay, has it plotted anything? Are you able to see this?
Yes.
So this is not an interactive chart, therefore it is very difficult to interpret this. So I'll close this firstly and I'll make this interactive. So here interactive is equal to false. This has to be just changed to true. You can see here, this is how it comes.
Okay.
Layout, I can just go to layout and change the layout here so that you are able to see a bit of a spread here. You can see this is your whole milk, all the products which are related to whole milk. You can see here butter, curd, citrus fruit, pastry, pip fruit, bottled water, so on and so forth. All of them which are related to curd. Then some of the products which are related to yogurt can be studied here. And whether there's a relationship between these two items can also be studied here.
Right.
Are we clear with this?
Yes. Yes.
Okay, let me just then we'll be moving on to what is called as Jaccard index. Have you heard of what is called as Jaccard index?
Uh,
Similarity index. Which items are very, very similar to other items?
okay.
So
You
this
call
is
it
your
a
Jaccard index.
Jackal. Okay. Yeah.
It's called as Jaccard index.
Okay. How do you spell it? Yeah.
JACCARD.
Okay.
It is called as Jaccard index.
It's a similarity index, isn't it?
Yes. Yes. And this is the dissimilarity index.
Okay.
You can see here dissimilarity or similarity, however you want to call it.
Okay.
So in the rows, you have different items here like root vegetables, other vegetables, and whole milk. In the columns, what you have is basically tropical fruit, root vegetables, and other vegetables.
Right.
So here, if the values, it shows the similarity matrix. If the value is closer to 1, it means that there's a strong association. On the other hand, if the value is closer to 0, it means that there is a weak relationship between the products. So root vegetables and tropical fruit, the association is 0.89, which means 89% by and large, they tend to be bought together. They are co-occurring items. So in the same basket, you can find these two products. So mainly eye-catching numbers are above 90, correct? You can see here rolls and buns and tropical fruit. Similarly, soda and tropical fruit, soda and root vegetables. These are all eye-catching numbers because the percentage of number, if you look at the Jacquard similarity, it is 0.92. Any number which is closer to 1 means that there is a strong similarity. Any other number wherein if the number is closer to 0, it means that there is weak similarity. Are you clear with this?
Yes, sir.
Okay. Now let us move on to certain graphs here. Right. What I'll do is basically I will show how to construct plot.
Okay. So even with this method, we can also find it out, like in a certain area, if we have the data. So in certain grocery shop or any kind of a shop, what kind of a items to be keep there so that the customers can buy the same.
Yes. So actually, if the lift value is greater than 1 for certain products,
Okay.
those items can be positioned together.
Okay.
If the lift value is negative, those items should be kept far away from each other.
Okay.
So here you can see here the different items that are coming. I hope you can see properly.
Yes.
So items in the LHS, you can see all the rules here, and you can see certain blue circles here. So larger the blue circle, higher the lift. Smaller the blue circle, lower is the lift. That is a very simple thumb rule. So you can see certain big rules here for which is this item sausage and other vegetables. Similarly, sausage and rolls and buns, sausage and soda, sausage and whole milk. These are the items which have a strong relationship. That's what we can say.
Okay.
On the other hand, if you look at somehow compare this, these circles, these are tiny circles, which means that the lift value is very, very low. So whole milk, sausage, and other vegetables, people are not buying that much. Similarly, if you look at rolls and buns, sausage, and soda, people are not buying it that much. That is the meaning behind this.
Okay.
Okay. Now,
Yes.
next is what is called as parallel coordinates plot. Let me just show you one parallel coordinates plot. Are you able to see this?
Correct.
So you can see here uh, all the items, and here in the x-axis you can see the position 1, position 2, and how people are, what is it leading to RHS. So thicker the red line, stronger is the relationship, correct? So you can see one thick line which is ending here, and this corresponds to root vegetables. So if you trace back the path here, mostly they are buying other vegetables and whole milk. So people who buy whole milk and other vegetables, they are the ones who tend to buy root vegetables. This is the purchase journey that we are trying to look at. So if you look at basically RHS here, this corresponds to other vegetables. Now here, people who buy chicken are more likely to buy other vegetables. There is no line here, which means that people who buy chicken immediately, they can be the next buy that you can expect out of them is basically your other vegetables. Is this clear?
Yes. Yes.
Okay. Now, one more thing which I wanted to sort of show is basically at a very high level. I just wanted to show the distribution of the different items. And for me to show the distribution of the different items, there is a package which I need to install, which is called as dplyr. Then basically there is one more library which I need to install, which is called as tree map.
Okay.
So in the entire store, how are the items being displayed, correct? So I'm just showing the relative distribution of the items. So you can look at occurrence 1, occurrence 2, and occurrence 3. This is just a simple frequency distribution. We are just visualizing it using a tree map. Just produce a tree map. Are you able to see this?
Yes.
So when you look at this, basically you have different products here, correct? So which means that the products are shown in rectangles, which means fresh products, processed foods, food, non-food and drinks. These are the ones which are occurring predominantly. So in the entire, if you look at the frequency, most of the items in this organization, and you can see here, almost 30% I can say, they are emphasizing on fresh products and processed food. And to some extent, basically, they are also showing drinks and non-food items. Larger the rectangle, more the frequency of the items. Smaller the rectangle, if you look at perfumery, canned food, it does not anyway consume so much of space. Detergents also does not consume so much of space. Therefore, the relative frequency of these items is shown in a smaller rectangle. Are we clear with this?
Yes.
Okay. Now, one more level deeper, if you want to go, this is, you can construct one more level of tree map. Correct? You can just construct a tree map. This is a tree map. Can you see here? You have the fresh fruits. Now it is giving you the breakup of the items. Within this rectangle, you can see mostly people are selling cheese, dairy products, delicatessen, shelf stable, and then there are also shelf stable dairy products and eggs. So within fresh products, which are the products which are being emphasized, that is what you can see here. Similarly, within processed food, which are the items which are being shown, like staple food, soups, condiments, health and food, sweeteners, so on and so forth. This is what they are basically showing, right? And within the drinks item, you can see the relative distribution of hard drinks, wine, beer, coffee, so on and so forth. Is it clear?
Yes.
Now, lastly, what you have is a tree map here. So you can see more granular, which are the items which are coming out, right? You can just see here meat and sausage, you can see perfumery, you can see detergent, you can see fruit and vegetables, and then you can see fresh products, drinks, and non-food items. Amongst drinks here, you can see which are the items which are getting distributed. Among snacks and candies, you can see the relative distribution of items. Among meat and sausage, again, you can see the relative distribution of the various items. Again, you have to go by the rectangle here. Smaller the rectangle, basically lesser the shelf space or lesser the number of items which are being sold. Bigger the rectangle, higher the number of items that are being sold here. Are you able to get this?
Yes.
Any questions?
So bigger the rectangle, the more sales there in that particular.
Yes.
Yes.
So this is about a priori algorithm. So any questions, please ask me.
So even the in the malls and all, so even this can work for
Definitely.
yeah.
Market basket analysis is extensively used in malls, supermarkets, when you have thousands and thousands of items to find out the product association, or what we
Right.
call as product affinity analysis. What I was showing is product affinity analysis or market basket analysis.
Okay.
Sometimes people also call this as product co-occurrence analysis.
Okay.
This is what is called as product co-occurrence analysis. So far, are we clear?
Yes.
Any questions, any doubts?
So this market basket analysis basically for that they especially the malls and other things, or any other application of this?
No, this is tailor made for malls, supermarkets, big bazaar, those sort of things. You can't use it in any other sense.
All right. Okay.
Mostly it can be used exclusively there. We can't use it anywhere else.
Okay.
Okay. Do you have any questions, or shall I move on to one small topic that I have after this?
We
If
can.
a priori algorithm is a priori is a non-super, it's not, it's an unsupervised learning technique. I hope so far it is clear.
Okay. Okay. Okay.
Good evening, sir.
Please ask me, madam. Yes, ma'am.
Sir, this particular analysis, so is it used for online shopping sites? Because when we purchase, they always the video pops up that you can purchase this with this product, particular product, like Amazon and such.
Madam, it's a wonderful question that you have asked, madam. Actually, this can be used. Whatever I'm showing, market basket analysis and such things are used in a offline setup.
Okay, sir.
Not really in
Offline
an
setup.
online setup. In an online setup, maybe on Saturday, if time permits, if I have sufficient time, I'll just show you. There are other algorithms which are used. As you're rightly pointing out, when you go to Amazon or Flipkart and let's say you buy items, then basically Amazon quickly recommends saying that if you have bought this item, people who have bought this item are also likely to buy another item. Or if you go to
Right.
YouTube and you watch a video, let's say Kishore Kumar songs,
Right.
next day it says
Right.
basically, okay, people who have watched Kishore Kumar songs have also watched, let's say, Mohammed Rafi songs. This movie can be, this song can be heard by you, right?
Yes, sir.
So
Yes,
here
sir.
you're seeing a very curious pattern, wherein all these online whatever happens, basically that is called as a recommendation engine. And to build
Okay, sir.
recommendation engine, there are other sets of algorithms which are mainly coming under the umbrella of what is called as collaboration filtering.
Okay.
Collaboration filtering. Yes, some of these algorithms may be borrowed there also, but mainly what they use under recommendation engine is collaboration filtering. Second most popular item in online retail space is basically online space, e-commerce space is basically they use an algorithm which is called as ALS, alternating least squares, or matrix factorization. Funk SVD, FUNK space SVD. These are some of the algorithms which are extensively used in the e-commerce space.
Okay. Thank you so much.
Okay, okay. If time permits, maybe in the last day, I'll just cover recommendation engine, madam.
Yes, sir. Thank you so much.
No problem, madam. Any questions? Any other questions you have? Any questions you have? Any questions you have?
Himbade sir, can you mute yourself? Yeah. Dr. Rabinder sir, are you there?
Yes, sir, I am here, sir.
Yeah, yeah. So yes. So do you have any questions on
No,
this
sir.
particular.
No.
Okay, okay.
Okay, just wanted to ask, can I cover a small topic that is segmentation now, or shall I do it tomorrow? If you're tired of listening, maybe we can just do it tomorrow, or else I don't mind covering one more small topic, maybe another 10-15 minutes.
Please, sir, do it. I think yes, we can. If something will be left, we'll take it tomorrow. At
Okay.
least we'll know the intro part of it. You can take it, and then if something will be left, so
Okay.
we'll take it ahead tomorrow.
Okay. So till yesterday, what we learned were mostly supervised learning technique, and today I introduce you to what is called as a priori algorithm, right?
So
The
this a priori is it is unsupervised, isn't it?
a priori is unsupervised.
Unsupervised learning. Okay.
It is
So
unsupervised. There is no dependent variable that we have used anywhere.
okay. So in machine learning, basically we use the supervised and
No, this is also part of machine learning. Whatever I'm doing, right, within machine learning, you can have supervised learning
supervised
or
and
unsupervised learning.
unsupervised both. Okay,
Yes.
okay,
So today, what we have learned is one example of unsupervised learning technique.
right.
So the next topic which I wanted to sort of cover is k-means cluster analysis. So it's
Okay.
a segmentation technique wherein you have a set of variables, right? And these set of variables that you have can be used to group people. It is used to group people in the sense that here there is no dependent variable. If I have got 10,000 customers, I want to group people. 5,000 of them are low profitable customers. Another 4,000 people are average customers, and then the balance 1,000 people are basically highly profitable customers, which implies that basically what we can do is when we have a set of variable, when we have a set of data, we want to group people based on characteristics. How can I group people? It has to be based on similarity measure, because there is no dependent variable here, right? We have to group. If I have to group people, how can I group? Maybe I can look at your age and your gender. So all the men whose age is above 40 and less than 50, we can put them in one bucket. And those people basically whose age is slightly on the higher side, 50 and above, you can put it in the second group. So you're looking at similarity in certain characteristics. So almost every measure that we use under segmentation works on similarity measure. So one such technique that we are going to learn today is what is called as k-means cluster analysis. K-means cluster analysis is typically used when the data is scale invariable. If you have a scale data, then you can use k-means cluster analysis. Else, we don't need to use k-means cluster analysis. Okay, and typically when we use k-means cluster analysis, the sample size should be greater than 1,000. Right? For small data set, it is better not to use k-means cluster analysis. Are you able to see this data?
Yes, now we are able to see.
Are you able to see this?
Yes.
So this is again a telecom data set wherein we have certain variables like region, tenure of the customer, age, marital status, address, income, education level, so on and so forth. Right? These are all demographic details and such things. But what I'm really interested in is basically some of the services that he has purchased. Look at some of the services that he has purchased, like multiple line, voice mail service, pager service, internet service, caller ID, call waiting, uh, call forwarding service, conference service, and e-billing service. So can you see some of these variables? We'll be using them to group and understand the service purchasing pattern. Service usage pattern is what we are trying to understand through k-means cluster analysis. Is it clear? We will just be
Yes.
using these variables, that is from multi-line to e-bill. There is no question of using demographic details and such things here. I will be using 1, 2, 3, 4, 5, 6, 7, 8, 9. These 9 variables I will be using to understand the service usage pattern of the customers. How to do this? We'll be doing this using what is called as K-means cluster analysis. Is it okay?
Yes.
Okay, let me just sort of, for momentarily unshare my screen. I will close all the unwanted windows because there are too many unwanted windows in my data set. It will just be unnecessarily confusing. Let me open up Jupyter Notebook. Are you able to see my screen, please?
Yes, screen we are able to see.
So this is what we are doing. We are doing what is called as K-means.
K-means.
Yes. The letter K here basically indicates the number of groups. K can be 1, 2, 3. It can be anything. File already exists. Oh, okay. I'm just typing the same name again and again. Okay. Let me just quickly run through some of the codes here. Python. So this is our friendly Python, which we are very, very comfortable with. So multiple lines of code I can execute. Let me quickly import the data set telco underscore extra. Okay. Right. ed.read underscore CSV. Just import this telco underscore. This is what it is. Are we clear?
Yes.
5 rows and 46 columns. We've just imported the data set. Now what I'm doing is basically showing you only the variables that I'll be using for analysis. I hope you are able to see this. Only the 9 columns I'm using: multi-line, voice, pager, and then basically internet service and e-billing service. We are interested in studying the service usage patterns. Okay. Now, one of the important things when we are doing segmentation is, you know what? We have to scale the data. Scale the data means basically we have to standardize the data, right? So because many times if the variables are in different units, for example, one variable may be measured in kgs, the other one may be measured in liters. We can't compare 1 kg and 1 liter, right? Because their dimensions itself are different. So therefore, what we do is basically we use what is called a scalar technique. We are trying to standardize the variables. Okay. And once we standardize the variables, we can make better comparisons. Is this clear? Basically standardizing. After standardization, every clustering technique, you have to standardize. There is no other option apart from standardizing. Okay. So the first question that we have to ask is basically how many clusters do you want to make? So you can see here, we are experimenting. This is experimental process. We have made 7 different clusters, right? We are experimenting and we'll just be seeing how many groups of customers are there. 2 clusters, 3 clusters, 4, 5, 6. What is the right number of clusters that we need to make? So let me just plot the same thing in a graph and show you. You can see here, this is how it appears, the clusters. Are you able to see here?
Yes.
Number of clusters, when you use a 2 cluster solution, basically the sum of squares is very, very high. If you make 3 clusters, basically the sum of squares is basically reducing. It reduces further 4, 5, 6, 7, 8, and 9. But for 9, basically it is coming very, very low. I would say either you try with a 3 cluster solution or 4 or 5. Are you able to understand? This is the drop that you are seeing. Either 3 is good or 4 is good or 5 is good. What is the optimal number of clusters? If you ask me, there is no rule of thumb. It is nobody can give you a rule of thumb. But as a based on my experience, if I have to tell you, it is 5 plus or minus 2. 5.
This is elbow curve, no?
This is elbow curve, madam. Based on the elbow, we can just decide the optimal number of clusters. Right? But many times you can just
So here,
overlook.
if we say that, as you said,
Please
may
go on,
I
please
say
go.
something?
Please go ahead, madam.
So as you said that there is no rule because it is unsupervised learning, and
Yes.
every if you say 5 or 6, it depends upon how the business want to deal about the number of
Definitely.
groups of the customers. So if they want to manage 5, then it is they can go with 5, or otherwise they can go with 6 also.
Exactly. Right. So there is no hard and fast rule that it should always be 3, 4, 5. Right. But the problem is if you have only 2 clusters, it means it may be, let's say out of 1,000 customers, 2 groups means what? I'm forming only 2 groups, which is very risky. 2 may be very less. On the other hand, if I form 7 or 8 clusters, managing 7 or 8 becomes a bit of a problem. So based on my experience, if I have to tell you something, I just use this thumb rule. It is just 5 plus or minus 2. 5 plus 5 plus or minus 2. So your optimal cluster will usually be either in this group, it is basically either 5 minus 2 or put a comma and say 5 plus 2. Anywhere within this region, you will get the solution, which means what? 5 minus 2 is what? 3. Put a comma here, 5 plus 2 is 7. So anywhere between 3 and 7, your optimal cluster solution will lie. I've never seen in my entire career anybody go with a 2 cluster solution. 2 cluster solution, maybe while explaining to students, we may explain. But in the real time scenario, nobody forms a 2 cluster solution because it is very less. 3 cluster solution, yes, I've seen people go with 3 groups. You can experiment with 4 or 5. 6 is very rare. 7 is very, very rare. Beyond 7, I've never seen anybody go. So if the data set is very, very large, then maybe you want to make 6 or 7 groups. But for all practical purposes, either a 4 cluster solution or a 5 cluster solution, or at best 6 cluster solution. These 3 groups, these 3 criteria is what you can look at. Don't go beyond 7 and such things. It is just a waste of time.
Sir, but
yes.
it is with respect to customer segmentation. Yes, you are right. Like managing 7 or 8 cluster will be a big is not a good thing. But on the other side, if we were discussing with our colleagues, like there are problems like suppose if we are having a set of players all around the world, and we are having just the information about that latitude, and these 2 parameters are there if we want to just identify that how many countries have participated. So again, we can apply k-means clustering, but here that k-means clustering will give us the number of right number of approximate number of countries actually who has participated in the games maybe. So in that case, the cluster number may rise.
Yes. If you want to know the approximate number of countries that have participated, you can just look at the country list itself, right? You don't need to group anything.
Sir,
There are
that is right. No, that is right. If the countries itself are mentioned. So, but
Yeah.
if the suppose only latitude and longitude information is there, only information is there, and you
Yes.
have no other reference to find out the thing, so then we can use in this algorithm can be used in this for this way also, isn't
Definitely.
it, sir?
Definitely you can use it. Definitely you can use it. Definitely. Very useful algorithm. You can use it. Latitude, lat long variables you can take and group all the different nations. You can do it. Not a problem. I hope that's clear, madam. Anything else you wanted to ask?
No, sir. It's really nice you have explained.
Okay. So let me just experiment. I'm just saying experiment because nobody can, I can build a 3 cluster solution and feel happy. Somebody else may build a 4 cluster solution and feel equally happy about his solution. There is no right or wrong answer here. At the end of the day, it's a very subjective procedure, right? So my 3 cluster solution, I feel it's very good. Somebody may build 4, still somebody else may build 5. But as a rule of thumb, I'm just saying 5 minus 2 should be decent enough. So when we are building a 3 cluster solution, you can see the group membership. So 0, 1, 2, the first person has been assigned in group 0, second fellow has been assigned in group 1, third fellow has been assigned in group 1, so on and so forth. So that is where, and that is how basically group membership is basically allotted, correct? Segment group the customers into individual segments. Okay. I want to see the cluster label against each and every individual. Can you see here? So based on this, the first customer has been put into group 0. The label is 0, but it's actually the first cluster. Second fellow has been put into group number 2, but the label is 1. Python starts from 0. Python has a 0 based indexing, which means that the first number it counts from 0, then 1, 2, 3. R has a 1 based indexing, which means that the first record will be starting from 1. So here the group 0, right? Cluster number is 0, right? Then second individual has been put into 1, so on and so forth. So each individual you can see here has been put into one of the 3 classes. Now, what is the fundamental? There are only 2 questions that you need to ask in clusters. How many clusters? That is the first question. Second is basically what do these clusters represent? If you are able to answer this wholeheartedly, if you have been able to answer this question, with clarity, then your segmentation solution is right. On the other hand, if you're not able to answer this question wholeheartedly, in the sense that if you have some ambiguity in your mind, how many clusters you're not clear, what do these clusters represent, we are not clear, then your cluster solution will never see the daylight. So fundamentally, we are trying to experiment with a 3 cluster solution. That is the first question. What is the optimal number of clusters? 3. Why 3? You can just use the thumb rule. What is the thumb rule? I've just now showed 5 minus 2, or you can use the elbow curve. What do these clusters represent? So to understand what do these clusters represent, let me build the cluster profile. Let me build the cluster profile, right? What is first cluster? What is second cluster? That is what I want to know. So you're getting certain crazy numbers here, right? So 0, 1, 2 along the rows. And for each of these variables, you're getting certain numbers. So what I want to do is basically, I want to put this in a heat map and show you how we can make some sense of this. np dot, okay. This is my cluster profile. I've just rounded this off. Okay, I think I have to use a heat map. The command for heat map is what I need. I think I can borrow this command from my linear regression code itself, which I was using earlier. Instead of typing everything once again, let me just I will just put this in a heat map, the same right? I'm borrowing the same command, copy pasting original command. So this cluster profile is there. Instead of this X, let me just use cluster profile. Heat map should come ideally. Okay, since it is not able to understand. Seaborn as SNS.
So see,
Yes, Seaborn. Okay. The output has come here. Okay, now what I'll do is this color is not very friendly. So let me just change the color. I think red, yellow, green are basically easier to understand. Let me see. Okay, are you able to see this now?
the comma has to be there after.
You're able to see this, right?
Yes.
So there are three clusters that we have formed. Cluster 0 is the first group, cluster 1 is the second group, and cluster 2 is the last group. You see here, large numbers are highlighted in green. Green means basically all higher numbers, and basically yellow means basically moderate numbers, and red means basically smaller numbers. So you can just see here all the green numbers. All the green numbers are here, and these are your individual variables. So which means that people who belong to the cluster 2, they are the most profitable customers because they are using almost every service here. Correct? But predominantly you can see here 0.87. This is the largest number. 0.89 is also largest number here, which means mostly they're using voicemail service. They're using pager service. They're also using call forwarding service. Some of them are using conference service and call waiting service. Every cell here is green, which means that basically they're contributing a lot. They're using each of these services. Now look at cluster 1 here. Some of these cells are green, some of these cells are red. Green means basically high number. So people who are belonging to cluster 1, mostly, very interestingly, they're using call ID, caller wait, conference service. They're not using e-billing service, call forwarding service they're using, and that's it. Which means people who belong to cluster 2, they're using caller services mostly, either caller ID, call waiting service, or conference or call forwarding. So these are the people who are using caller services, caller ID services. And you look at cluster number 0, every cell is either red or it is barely yellow. Since maximum number of red cells are occurring in the first one, you can say people who belong to cluster 0 are least profitable customers. They're not really using a lot of services. Since they're not using a lot of services, they're also not spending a lot of money on these services. So cluster number 0, very few services. Service usage pattern is very less. At best, maybe they're spending on e-billing services. Some of them may be using internet services or multi-line services. That's it, nothing more than that. Cluster number 2 are the most profitable this thing, because you see a high number for each and everything, and this is nothing but the group mean. Within that cluster, what is the mean value for each of the services? When you look at cluster 1, some of them are green and some of them are red, which means cluster 1 are moderate spenders. Cluster number 2, big spenders. Cluster number 1, moderate spenders. Cluster number 0, poor spenders or weak spenders, and therefore you can call them as cheap customers. So this is how clusters you can just sort of experiment with, right? So I have built a 3 cluster solution. If you want, you can just experiment with a 4 cluster solution as well. You can see here the code somewhere here. I think we typed k means of 3. I've typed. Instead of 3, you can just give it as 4. You can experiment with a 4 cluster solution. Then you type 5. You can experiment with a 5 cluster solution, so on and so forth. I hope this is clear. Is this clear? Any questions you have, any doubts you have, please? Any questions, any doubts, please?
No, sir.
No,
No, sir.
Okay. Are you able to understand cluster solution?
Yes, sir, definitely.
It's a typical example of an unsupervised learning technique. So we learned market basket analysis, how to do this using a priori technique. And then basically we have learned, your clustering technique. K means cluster analysis, right?
Sir, what you will be covering tomorrow?
Tomorrow, mostly, madam, in the first 1 hour, I'm planning to finish off with PCA or principal component analysis. And if time permits, I'll also try to do, I'll also try to do a bit of time series analysis, madam.
Sir, will it be possible for you, whatever examples you have taken, can you share the script of those?
I've been sharing regularly, madam. Each of these days, whatever I've covered, I've shared it with my colleague who
Yes,
has
yes,
in turn shared this.
definitely. We have got till now.
Sure.
But you be sharing with all the for all the examples?
Yes, yes, yes,
Yeah.
yes.
Thank you, sir. Thank you.
No problem, no problem. My one request is basically that WhatsApp group, I think, which you have created, I have not been included.
I
Kindly
will
include
take
me.
you. Just a second. Yeah.
Sure.
So
Sure,
we'll take you here.
Just that I can maybe share and connect with participants. That's the only thing.
No, that's true. That's true. There is nothing. I'll take Kanchan also. So both of you there. So anyone wants to say something? Want to give any remarks at the end of the session? Baljit ma'am?
So
So it
feedback
has
form
been
is not accepting
it has been
responses.
a nice discussion.
Uh,
It has
so,
been a nice discussion on all
so
over these days, and he has very nicely explained all the concepts of machine learning, artificial intelligence, and the flow has been really nice. The way he started with the initial discussion with linear regression, then logistic regression, random trees, random forest, and today the, the flow has been very nice and excellent.
Supriya ma'am, you wanted to say something? Okay, so yeah, so it comes to the end of the session. Yeah, Supriya ma'am, you want to say something? Her voice is not coming, maybe some problem. So now here comes the
Working for time now. That is.
your voice is breaking off, ma'am. Yeah. Can you repeat it, Supriya ma'am?
Sir, feedback form was not working. Now it's working, sir. Thank you.
Okay. Yeah. Okay. So Mithun sir, once again, thanks a lot for conducting a beautiful session on the cluster analysis and also giving so many business examples, and that really that gives a more clear picture of the businesses, that how it is being run on the based on the machine learning and the artificial intelligence. So we are thankful to you, and thankful to all audience too, the our participants, those who are with us since day one. So thank you everybody, and we'll be meeting tomorrow at the same time at 6:50, and we'll continue with this session. Tomorrow we'll have Dr. Mishra also. He wanted to share some, so we'll be taking him around 8:30 or 9 o'clock. So before that, Mr. Mithun will be taking it, and so we'll be like having a more clarity on this machine learning and the deep learning. So thank you so much. Thanks a lot, Mithun sir. Thank you everyone. We'll take a break off for today.
Good night, sir.
Good night, sir.
Thank you
Good
very
night,
much,
sir.
sir. Good night, sir. Bye.
Good night, sir. Good
Thank
night.
you.
Bye bye.
Good night, sir.
Thanks.
Bye.
Good
Thank
night, sir.
you. Good night.
Good night, sir. Good night, ma'am. Yeah.